Hello, we are discussing about GATE 2000 ECE paper, and the topic we are discussing is digital circuits. This is 5 mark question came in GATE 2000. The operating conditions of 3 pumps XYZ are to be monitored. On implies nothing but 1, off implies nothing but 0. So for example, x is equal to 1 implies nothing but the pump is on, x is equal to 0 is nothing but pump is off. And it is required to indicate the LED on the panel that should glow when a majority of pumps fails. Whenever the majority of pumps fails, LED should glow. So A bit. Enter the logical values in the K-map in the format shown in figure 15A. Okay. And derive the minimal Boolean sum of products expression whose output is 0 when a majority of pumps fails. Next, the above expression should be implemented using logic gates, and P is the output of this circuit. P is at 0 volts when a majority of pumps fails and is at 5 volts otherwise. Okay, P must be at logic 1, P must be at logic 0 whenever the pumps fails, otherwise P must be at logic 1. And design a circuit to drive the LED using this output. Okay, design a circuit to drive the LED using this output. The current through the LED should be 10 milliamperes and the voltage drop across it is 1 volt. Assume that peak and source are sink 10 milliamperes and a 5 volt supply is available. So first, given that one, there are 3 pumps XYZ are there and they have to be monitored whether the pumps are on or off. Okay, so whenever the majority of the pumps, that is nothing but 2 out of 3 or 3 out of 3 are going to be fails, at that time we must LED has to glow. Okay, so that first of all we are going to enter into the values. Okay, the entering of the values is nothing but here we are going in this way, and we are concentrating on the P. P is nothing but logical. This is P is equal to 0. P is equal to 0 when majority of the pumps fails. When P is equal to 0 volts, P is at 0 volts. Look at this one. P is at 0 volts when majority of pumps fails. Majority of pumps fails. That implies nothing but fail is nothing but 0. 0 implies nothing but complement. Whenever there are 2 complements or 3 complements for the minterm, at that time that is nothing but failure condition. So where you have to place 0 and in otherwise it has to be placed 1. So we are writing this one, this K map in case for the P. So this is x bar yz, this first one, x bar y bar, both are going to be zeros, so that the pump fails. And x bar y bar z bar, pump fails. X bar y z, okay, pump won't fail. Okay, this is pump won't fail, that is nothing but 1. X bar y z bar, that is nothing but again it is 0. And x y z it is 1. X y z bar it is 1. X y bar z it is 1. And x y bar z bar it is 0. So this is what we are going to get. This is the K map for the above problem condition. And now we are going to express P. P can be written as by combining ones. So if you combine, the ones can be combined in this way. So these two ones can be combined to get a product term, and these two ones can be combined a product term, and these two can be combined for a product term. So P is equal to, you are going to write the expression for this one. P is equal to xy plus, okay, yz plus xz. This is what you are going to get. P is equal to xy plus yz plus xz. That is, whenever the majority of the pumps are on, by that time P must be 1. Whenever the majority of the pumps fails, P must be 0. That was given. Okay, so P is equal to xy plus yz plus xz, and this output, okay, and realize this one with logic gates, and later use this node P, okay, use this output to drive the LED, and the current flowing through the LED is minimum of 10 milliamperes and the voltage up across LED is 1 volt. Okay, and assume peak in source or sink 10 milliamperes. So now we will draw this circuit. P is equal to, P is equal to, given that one, P is equal to xy plus yz plus zx or xz. So for that one, what we require is nothing but we require three two input AND gates. For that one, you are going to give the inputs as xy, yz and xz, so that you are going to be getting three product terms, and those three product terms should be get ORed to get P, so that there is a 3 input OR gate is going to be required. That is what it is required as P expression, whereas it is OR gates and others are going to be AND gates. So this has to drive an LED. That LED is going to be connecting in this way. Okay, LED is going to be connected from plus 5 volts and through a resistor. Okay, current limiting resistor, and this is going to be a diode. This is symbol for the LED. Okay, LED, and the output of P has to be connected to this one, so that now the point P, the output of this circuit, is driving the LED. Whenever P is equal to 0, LED has to glow, and we know that when LED works on forward bias principle. That is, whenever P side voltage is going to be more than N side voltage, that is whenever the voltage on P side, that is anode side, is more positive than cathode side, at that time diode comes into forward bias, where the LED emits light in the forward bias. So whenever P is equal to 0, LED has to be on. LED should be on whenever P is equal to 0. By that time a current flows in this direction. Okay, so by that time current flowing through the LED is 10 milliamperes. Current flowing through it is 10 milliamperes, and voltage drop across this one under forward bias is 1 volt. Okay, so by that time what should be the value of resistor, that is driving circuit? R is equal to, we can write it as, the value of R is nothing but 5 minus 1 divided by P is equal to 0 is nothing but 0 volts, we will think. Okay, 5 minus 1 divided by 10 milliamperes. 10 milliamperes, that is nothing but 4 by 10 kilo ohms. So simply it is 0.4 kilo ohms, which is nothing but 400 ohms. So the driver circuit is nothing but consisting of power supply, resistor and LED. So this is going to be called the power supply, and R is going to be treated as a driver circuit which drives the LED. Okay, so the required value of R is nothing but 400 ohms. So this is what asked in the question. We have to fill up the K-map according to the problem statement. Later we are going to get the minimized expression and realizing with logic gates. This is the diagram for this one. And later we are generating a, we are drawing a driving circuit. Okay, so the value of R is nothing but driving circuit resistor, that is 400 ohms. Thank you.